this question relates to question number 7 of the National 5 2015 paper. We're going to be looking at 7a part 2, which is down here. And it says, determine the direction of the resultant force relative to the 8 times 10 to the 3 Newton force. So the first thing I want to do in here is just draw in a diagram of the forces again, just to remind ourselves of what's going on. We had the 8 times 10 to the 3 Newton force going along this way. That's the force due to the engine. And we have the 6 times 10 to the 3 Newton force downwards due to the tugboat. If we look back at the diagram, that is a correct drawing of those two forces drawn to find the resultant force, which is this blue line here, which is the 10 times 10 to the 3 Newton force that was determined in question A part 1. So I suppose first of all I should put in that value, so we'll put that in here. That's 10 times 10 and to the power of 3. So that's the all the forces in the diagram drawn correctly. So let's now think about the question. What we want to do is to determine the direction of the resultant force, i.e. In what direction is that arrow pointing relative to the 8 times 10 to the 3 Newton force. And this is really important here. Relative to the 8 times 10 to the 3 Newton force means we don't want to draw our direction as a bearing from 0 degrees or from north. We want to figure out what is it relative to this value here. So I guess the key thing is we're looking for the angle, which commonly we would use in physics as the symbol theta. So we're looking for what that angle is in there relative to this 8 times 10 to the 3 Newton force. So the way to do that is to look at all the three values and come up with some trig relationship that can work. So if we think about these two, first of all, this is 6 times 10 to the 3 and this is 8 times 10 to the 3. That is the opposite and this is the adjacent. So SOHCAHTOA, tan equals opposite over adjacent. So there is our problem solved effectively. So what we'll do over here is we'll add in some text. Tan of theta is equal to the opposite, which is 6 times 10 to the 3. I'm just going to put in 6 because the times 10 to the 3 will cancel on both sides. And that's over the adjacent, which is divided by 8. And so that's the relationship that we can use to find theta. And so therefore, what we can then say is that theta is equal to the inverse tan of that calculation, which is 37 degrees. So I'll just put that in a nice place. And there we go, that's our answer. Obviously you would put in the degree symbol, and I don't have the degree symbol function on here, so you would add that in, that would be your unit. Well, actually, it turns out that I do have it, so we can add it in like that. Just a couple of other options, of course. You could find out theta by using any of the other combinations. So cos is adjacent over hypotenuse, so you could use 8 over 10. Cos of 8 over 10 would give you the same value, or sine, and sine is opposite over hypotenuse, so the sine of 6 over 10 would also give you the same value as well. And if you wanted to do it by scale diagram, which you could do, then you would measure the angle with a protractor, and as long as you got that value to be 37 degrees plus or minus a couple of degrees either side, then that would be correct as well. But in closing, just to reiterate, the important thing here is that we're measuring our resultant force in relation to this 8 times 10 to the 3 Newton force. So that's this angle. It's not as a bearing from north or anything else. That's what we must do to get the full 2 marks.